Welcome back to our channel. Today we dive into a crucial aspect of water treatment plants, the electrical control panels. These panels are vital for the operational efficiency, safety and automation of the entire water treatment process. Let's break down their components one by one. But before we go into them, so what are the career paths in water treatment control and automation? So upon successful completion of this course or any other course, if you are pursuing a career in water treatment, control, and automation, the first possible pathway you can have is becoming a control panel technician, where you'll be doing the installations and maintenance of control panels. Or you can become a mica engineer, where you can be working as a project engineer or as a design or even maintenance engineer. Or you can become a control and automation engineer, where you'll be probably focusing on the design of control systems. Or you can be a commissioning engineer, where you'll be focusing on project commissioning. So when a project is commissioned, there's need of commissioning engineer. These guys, they'll actually make sure that the plant is operating according to the designs. And if there are some mismatch, they will still be able to do fine tuning of all the processes involved, like from the mechanical, the process side, as well as the control and automation. So let's dive deep into our tutorial today. So our tutorial today, we are focusing on control panels. The reason why I probably chose to talk about control panels as this course or tutorial is starting is so that there are many people who might not be aware of what a control panel is. So if we can actually go into them, you will have an idea of what a control panel is, so that as we go deep into all the components of the control panel and how all those things work, you have probably an image or a better understanding of what we are talking about. So that's the reason why I chose to do this tutorial today. But all the components that we will look at today in passing, they will be tutorial which are in depth, full of information, where we will cover each and every component that we are going to be covering today. Right. So from the image there, you can see that there is a treatment plant there, and that building probably at the middle is where the control panels they are housed. So for such a plant, the number of control panels will probably depend on the parameters that are being controlled, and it also differs probably with country to country. Like in some areas, if you have got some pumps and some chemical dosing taking place, there there should be a standalone control panel for pumps, and there should be another for disinfection, and there can be another for other chemical dosing. So that's why I probably just made this illustration, so that you can have an idea of what is taking place. So in this example, in this picture that we can have equipment which which can be located around the treatment plant, but our panels, they might be localized in probably one central building, or they can be several buildings, and there can be some control panels there. Okay, so let's get inside today's tutorial. So the first thing that we're going to look at are control panel enclosures. These are protective housings that safeguard the internal components against dust, moisture, and physical damage. The material used can vary, including steel, aluminum, fiberglass, or plastic. Panels can be mounted on the floor or they can be suspended. They can also be one door or double door. And also, cable entrance can be under the panel. That is, if there is a cable duct in the building, or the the cable can use the top entrance, and in that case, a cable tray will be required. Right. So the control panel enclosures, once again, these enclosures, they are classified by what are known as NEMA ratings, which indicate their ability to resist environmental factors like dust, as we have mentioned in the slides before. And for example, we can have a NEMA 4X for washdown applications. Additionally, we have ingress protection or IP ratings, which show how well an enclosure is protected against dust and water getting inside the panel. So most of these panels, they will have an IP rating. It's actually a requirement that they should have an IP rating which will be displayed on the panel. Then probably the last thing about the panel enclosure is that the door on the front of the panel enclosure, usually it is fitted with emergency stop buttons, which consist of normally closed switches, and it usually has an emergency shut down button reset. And they can also have some rotary switches on the front door. So these rotary switches, they can be used probably to change from auto to hand. And also on that front of the control panel, as you can see in the image, there can be several lights, green lights, red lights, orange lights, and each it will indicate um, a different condition within the control panel. Right. Then inside the panel, usually there will be a fan or heater, like depending on where the panel is located. Some areas it is too cold, in some areas it will be too hot, so there will be a fan or heater which probably are controlled by some kind of thermostat, so that the temperature can actually be within an acceptable range. Right. Then the panel should also have a laptop socket to allow for maintenance works. Let's say there is need maybe to change the PLC program, so the technician should be able to have somewhere where they can plug their laptop as they can do that. Right. So within the control panel, inside the control panel, there are many components that we can consider as non-electrical components, but which are key components of a control panel. For example, we have the mounting frames or the DIN rails. These mounting frames or the DIN rails, this is where the control panel components will be mounted to. And also, a control panel should have wiring ducts. So this will make sure that there is efficiency in cable routing, and also to minimize noise. Like for example, for analog signals, these are signals which will which are from a range. Like for example, the most common is 4 milliamp to 20 milliamp analog signal. So if if the if the cable are not using proper ducts, that signal can actually be affected. So that's the electrical noise being referred there. Right. So the next thing that we are going to do is, right. So now what we're actually doing is to go through the most common components that you can find in a control panel. Yes, we are probably focusing on control panels for water treatment plants, but their basic function is the same, whether it's manufacturing, it's in mining, it's in building automation. It's still the same things, and they work exactly the same way. But in this one, we are probably just focusing specifically on water treatment plant, because that's my area of specialty, and we would actually be using some real projects in this course, right? So the first component that we are looking at is the contactor. This is an electrically operated switch that controls high power circuits. In water treatment plants, it's essential in engaging pumps and motors via control signals. So there is a whole lesson about contactors where we will cover them in much detail and show you how they work, how they are connected. Like, for example, we have several motor driving circuits that use contactors. So we have a lot of information that will be coming regarding contactors. Right. So, then the next thing that you can find in a control panel is a relay. Basically, a relay and a contactor, they actually work uh, more or less the same way. And maybe one particular difference is that the contactors are for three phase and the relays for single phase. So relays basically they are electromechanical switches that open and close circuits based on inputs. They are perfect for turning on alarms, trigger pumps under specific conditions. And we also use these ones a lot in control circuits. So there's a whole section where we will be doing the control circuits using relays. Right. Then we've got variable frequency drives. So VFDs, these they adjust the speed and torque of electric motors by altering the frequency and voltage supplied. This is critical for optimizing energy efficiency in pumps, and they pl- they play a very crucial role in minimizing the startup currents for pumps, especially when we are using bigger pumps greater than 5.5 kilowatt. We usually use variable frequency drive so that we reduce the inrush current and also allow for smooth operations. And also in some case where maybe you've got some pumps and maybe the flow rate, they you want to be able to change the flow rates. So you can actually use a VFD where at 100% the VFD or the pump will be supplying the full flow rate, but the VFD can actually be programmed maybe to run at 80%, which means even the flow rate it will be at 80%. So you can actually use this to play around and adjust some of the processes that you can find on a water and wastewater treatment plant. And usually for all pumps which are 5.5 kilowatts and above, we use variable frequency drives, right? Then we have the MCB. So for all our circuits, or rather for all the equipment that we have in the control panel, each and every component should have its own circuit breaker. So these are devices that automatically cut off the circuit during overload or short circuit situations so that we can protect our equipment from damage. And we can also use them even for isolating individual components in our panel. Then we have the MCCB, the molded case circuit breaker. This actually works more like an MCB, but these ones they are for large electrical panels and they are rated up to 1000 amps, and also they offer better protection than MCBs, and they can be adjusted to suit um, a range of currents. So we will have a bigger section where we talk about this, and where we look at some trip curves and how to read the trip curve, how to select these things. So we have a lot of information that will be coming soon. Right. Then the next thing that we've got transformers. So usually what we have in a control panel is that the incoming power is usually either probably 380 volts to 400 volts, and we will be using that probably to power high energy use equipment like maybe pumps, blowers, compressors, and the like. But we also have some equipment within the panel that require less voltage. Like, for example, you can have a PLC that require maybe 110 volts AC. So we will need a transformer that will step down from 400 to 110 volts AC. So in some panels, we have some transformers. Then we have got our PLC. That's the programmable logic controller. The PLC, it has got a CPU, which is essentially the brain of the PLC. These rugged computers, they automate and control equipment, and they do some complex logical operations. So the PLC is the one that will be sending the instructions, like when the pump to turn on, when to stop. So what will be happening is that there will be some communication between these field devices and the PLC. There will be like back and forth communication, because for a pump to run, it will require a signal from the PLC. But before the PLC can send that signal for the pump to run, like maybe there are other things that needs to be checked, like maybe what is the flow meter reading, if there are any chemicals, maybe we've got level sensors and the like. Some signals will be sent to the PLC. The PLC will assess, and then it will send an appropriate command to whatever device that is being controlled. So the PLC is probably, it's the heart or the brain of the system. Everything is probably centered upon the PLC. It is one that is doing the logic or the reasoning, and say, okay, fine. So at this point, this has to happen, or at this point, this process can happen, or at this process, or maybe it's programmed to do a certain process, but it will assess to check if all the set parameters are okay. If not, then it will decide and not run. Right. Then we've got switches. These are used for 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 switching on and off some devices and equipment, and you can also use them to isolate equipment within the control panel. Then we've got the HMI or the displays. So some panels, they will have these VDUs which shows the status of the process controls, and you can actually be able to also even control some of the processes via the display units. Then we've got power supply, right? So for power supply in a control panel, basically what we have are two circuits with what we call a power circuit and a control circuit. So for the power circuit, we have a three-phase voltage that we'll be using to run the pumps, the motors, the actuated valves, right? But then we have the smaller components like some relays. So we want to have a DC supply for the relays, and we can also have some PLCs that are that are powered by DC. So in that case, we need to have power supplies within the control panel. So what happens is that this power supply, it will be supplied by 400 volts AC. and it produces either 12 volts or 24 volts DC output, and that DC output is then supplied to the smaller components that use the DC. So that's the purpose of the power supply within a control panel. Then we have the motor protection. So overcurrent and overload are devices that are used to protect motors. And we have a whole section about them later on where we go deep in sizing them, selecting them, where we are going to do some calculations about the inrush current and how to size overload and overprotection. So make sure that you have subscribed to this channel, share with your friends so that you all will not miss this, right? Then the next thing, the input output modules. Well, so our PLC, since there is need for it to communicate with outside devices, then there is need for a module where we can do the connections, like the inputs and the outputs. So for the inputs, we've got two types: the analog inputs and the digital input. So the digital input, these are the on off, the true or false kind of scenario, like the light switch. The light can either be on or off. There is no other state. But maybe for a for a chemical tank, it can be full, 90%, 70%, 60%, 50 or zero. So this is how an analog signal works. It is a range from the set 100 to 0. So usually there is a signal, a 4 milliamp to 20 milliamp analog signal that is used, and so the 4 milliamp, the lower end, can represent 0, and the 20 milliamp, the maximum, can represent 100. Then anything in between, so it will just be a calculation that if 20 is 100, so what is 15? That kind of scenario. So that's an analog signal there. Then the network switches. So we have got devices in the field and they have to communicate with the PLC. So there's need for a communication channel. The same way we we do with internet. We can use Ethernet cables. We can use radio signals. There are a lot of different ways these devices can connect, can communicate. So we'll talk about the Profinet and the like later on in this video series. Then sensors and switches. So since we are saying that the PLC, it relies on the input from the devices in the field. So there are various sensors that we are going to be looking at. So um so these are the components that usually make up the control panels. Control panels, they differ based on what is being controlled, but in most cases you will find that they will all have these basic components, and we are going to go through each and every one of these components that we've talked today in detail. So if this video was helpful to you, please kindly subscribe and share it with your friends. And if you've got any questions, or if you've got any other topic that you would like us to consider, you can drop it in the comments. Until next time, see you.